Composite design pattern. What's the composite design pattern, and when we use the composite design pattern, and why we use it, and how the structure of the files and objects in composite design pattern. This is a picture simplify the composite design pattern. We will discuss it later. Composite from its name, it's connect objects together. These objects will be the same and contain also objects from the same types. If we check this puzzle, we see that its images or pieces connect together to form the whole puzzle. And this rocket, we can see it's contain parts, and each parts contain parts. Also, if each part contain also parts, or it's a separate part. If we look to the folders in our system, we will see that the folder contain files and folders. Each folders contain files and folders, and so on. We can deal with these files separately. We can deal with the parent folder. When we deal with this folder, the parent, we can access the children without touching the children. Just we copy and paste and cut the folder, the main folder, and everything will be in this folder. The folder contains files and music. We will mention the composite object as a file or a folder, as a folder, and the song as a leaf or an object will not contain an object, just from the same types, which is a computer file or object. Okay, now let's see the composite from Wikipedia definition. The composite pattern is a partitioning design pattern. As we know, the composite it's from its name, partitioning. The composite pattern describe a group of objects, as we see the parts of rocket, or the pieces of the puzzle, or the folders and files, that's treated the same way as a single instance. Each part of the rockets can treat as a single, instance of the same types of objects. The intent of the composite is to compose objects into a tree structure to represent part-whole hierarchy. Implementing this composite pattern lets client treat individual objects and composite uniformly. What we mean the clients? The clients, we don't mean by the clients the people who try to buy something from you. The client here is the developer himself. Okay, the client who try to use your objects, the developer, anyone need to use these objects, we call him a client. Now, if I wanted to deal with our rocket, okay, it contain parts, and each parts contain a price and vendors. When I wanted to buy the whole rocket, or the start our rocket, I can deal directly with the rocket. If I need to deal with a part of this rocket, I can deal with the middle part, or the head, or the tail, and how it's the cost of the tail alone, and the middle and the head of our rocket. Okay, that's what composite. We can use composite when you see there is a parts over the parts, or another parts which the same type of objects. We can use composite. We will discuss examples in a few minutes. From my definition, the composite, it's component and contain components. we mean the component and contain components. If we defined an interface, this interface, we can implement this interface in a component. The component will contain a list of components implementing the same interface that the parent objects implement. Each component can be one or more components from the same type of parent component. Now let's see a simple example for the composite. Now we have the interface, our interface, the main thing in composite design pattern is the interface, because our objects will be the same structure from the same type. We can deal with any part as a part. We have the head of the rocket itself, himself, and the body of the rocket and the tail of the rocket. We can deal. What we mean with deal, we can just check the price of this rocket. We can check the price of the tail. We can check also all functions on the rocket object will be on each part of our rocket. Now we will discuss a graphic example. The graphic, we want to print a graphic. The square, every shape will be implement this graphic interface will have a print function. Okay, so when we want to use a composite design pattern, we have to define our interface to implement our object to implement this interface. Now, after defining the interface, we defined our objects, and the composite objects in our example in folders will be the folders, and the files also will implement the interface, but these objects will not contain an objects. It just have the same functions which in the interface without containing an objects. So in the rocket also example, we have the head will contain objects or parts. The head of the rocket will contain parts. Also the parts, until we reach the smallest part on our rocket, will not contain any parts. So which will be the red one here. Okay, easy. When we use the graphic, each composite will implement the add and remove object from our list of objects, which will contain. Each component will have add and remove. So we have to implement add and remove on each composite object. This is, I think, in my opinion, is wrong. We have to fix it. So each object, composite object, do not need to repeat the same code of add and remove. Okay? Now, in this case, we have to consider the solid principles, open and close. If the small part, we need it to contain a part. If we do not implement all the function as the same in the composite and the normal objects, we will face a problem with adding parts to our part or folder. We can't in the folder example, we cannot add files to song. We have to change the type of song to be a folder, then we have when we will add a files. So we have to consider that. Now, this is example show us how we can add a graphic to an object, another object. Here we have graphic 2, add ellipse 1, and the graphic 1 add the whole graphic 2 with its component. Okay, this is a simple example. Also, each piece is image and the whole parts are images. We compose these puzzles pieces together to shape the whole picture or the whole image. In our rocket, as we took each part of the rocket contain parts, and we can deal with the rocket as a whole, or we can deal with the header or the top of our rocket, or the middle, or the tail. We see that in each composite object we have to implement add and remove. So we have to find another solution so we can don't repeat add and remove to avoid repeat yourself in our principles, coding principles. So I will create abstract class which will implement add and remove and contain another functions, business functions. Each composite file will be extended from this abstract and implement the interface to be a composite design pattern. Yeah. When we use this is example when we have to use composite design pattern. In our company, we developed a lot of e-commerce. Each client need a specific requirement. When we develop the order for something like a car or a flat or anything, always they need extra things added to order. Like in our example here, when you order a meal, you need a drink, you need extra things, and each one of them will have a price. So we have to add the price to another to the meal price. If we treat the meal as an composite object implemented from let's say order composite class, the meal will be implement the order. It will has a price. Then when we add a drink to the meal, if the drink is also implement order object, then we can add the price to the meal, to the list in the meal. The price will be added to the price. So we can achieve open and close principle. So if you need anything to add to the order, if we implemented from the order composite class, which we say it's an interface, the meal implement this class, and the drink will implement also this interface, and anything extra will be implemented from the this class. Also, if the extra need to be to add and discount or anything, we will add it as a part of the extra. So we have a tree here. The meal, under the meal we will have drink. That under the extra will have an extra also, and so on. So we can anytime add a new thing to our meal without adding fields to define what this and the type and the nested things we do in the past. Why have I used abstract instead of interface? We have to use the interface and abstract, but we have two cases here. If the class is too large, we say that the our files add and remove are too large. In our example, add and remove, it's too large functions, and there is a small or a few classes will be implemented add and remove. So we implemented in these classes without implemented everywhere. So we'll use just the interface. The other case, when we do not know what the customer will require later, and he need to add things and things, we have to extend the abstract add and remove functions, so we don't repeat ourselves when we coding. Now, interface, you can't add component if we have an object implemented interface, and this objects can't contain doesn't have a list, so we can't add component to the interface. Okay, if we have abstract function with add and remove functions, we can add to the list without implemented the add and remove. Just we extend the abstract. Okay. Now, as we see, the folder contain folders and files. The folder also have files and folders. This is the composite. We can deal with the parent folder and the subfolders and files. That's all for today. Thank you for watching, and see you later.